Hi everyone. Today I'm going to discuss the complete solution of A levels maths P4 variant 1 which is mechanics 1 M1 October November 2019. So let's start. Okay, the first question is, a crane is lifting a load of 1250 kg vertically at a constant speed of v. Given that the power of the crane is a constant 20 kilowatts, find the velocity v. So it's a 2 marks question, so you shouldn't spend much time on this question. Okay, we know that the formula of power is P is equal to FV. Okay, so this means FV means force into velocity, but in this case the force will be the weight of that load. So I can write it as P is equal to WV. W means weight, or P is equal to mgv. So now we'll put the values. P is 20 kW, means 20,000 watts. And M is 1250. G is 10 gravitational acceleration, and V we are going to find. So this can be written as 20,000 over 1250 into 10 is equal to V, or V can be written as 20,000 over 12,500. So these two zeros will be cancelled with this. So V is equal to 200 over 125, which is 1.6 meters per second. This is our answer of question number 1. Okay, now question number 2. Question number 2 is, a total mass of a cyclist and her bicycle is 75 kg. The cyclist ascends a straight hill of length 0.7 kilometers inclined at 1.5 degrees to the horizontal. So it means we got a straight hill. I got just this page, I think. Let me just confirm. Yes, I got this. First of all, we will draw the vector diagram, which will help us a lot. Let's suppose this is the slope. The length of this slope is 700 meters, because 0.7 kilometer means 700 meters, and this angle is 1.5 degrees. Actually the 1.5 degrees is so small, so let's make a much wider angle so that we can see it clearly. Let's suppose this is the cyclist at this place. Let's suppose this is the cyclist. Now the weight of cyclist is always acts downwards. This is 75 kg, so weight is mg. Mg means weight is mg. Mg means 75 into 10, which is 750 newtons. So this weight is 750 newtons here. So I'll resolve this weight vector into weight force. Force is a vector into its rectangular components. One is horizontal and one is vertical. So this angle is also 1.5 degrees. Always this and this angle are same. So this is 700, 750 cos 1.5 degrees, because this is the horizontal component. This is vertical component, which is 750 sine 1.5 degrees. Okay. So this is our vector diagram. Now our speed at the bottom of the hill is 10 meters per second. The speed here is let's suppose u, which is 10 meters per second at the bottom, and at the top the speed is 5. So for example, at this point our speed is v. This, let's suppose this is a, this is b. So at b the speed is 5 meters per second. There is a resistance of motion and the work done against this resistance. There is a resistance, so it means mu is there, the coefficient of friction is there. So work done against this resistor as the cyclist ascends the hill is 2000 joules. So work done against friction 200 joules. We should keep in mind this. Now the cyclist exerts a constant force of magnitude F newtons in the direction of motion. Means cyclist is exerting force in this direction. Find F. We need to find F. Okay. So first of all, the initial kinetic energy, this is 1/2 mu square, which is 1/2 into 75 into 10 square, and this will be like 3750 joules. This is initial kinetic energy. Final kinetic energy is 1/2 at this point B into mv square, which is 1/2 into 75 into the speed at B is 5, so 5 square, and this will be, after calculation, 937.5 joules. So this is the final kinetic energy. Also, the cyclist got some potential energy here, because cyclist gained some height. What is the height? This is the height, and if you see closely, ABC is a right angle triangle. So we got 700, the resultant. So that's why this can be written as 700 sine 1.5 degrees, because this is the vertical component, this is the horizontal component. So this height can be called 700 sine 1.5. Okay, therefore gain in potential energy, because cyclist got some potential energy at B, so that is mgh. So m is 75, g is 10, h is 700 sine 1.5 degrees, which is, after calculation, 13743 joules. This is the gain in potential energy. Now, uh, now you should look this diagram carefully. At this point A, the cyclist already got kinetic energy. And the second thing, the cyclist start applying force upwards. So it means cyclists start doing work from point A till point B. So at this point, cyclists got initial kinetic energy plus started working from this point. So there are two things at this point. What are those two things? Those will be work done plus initial kinetic energy. So from this, at this point, the cyclist got some initial kinetic energy and started work done. So that's why I added them. Work done plus initial kinetic energy. And at point B, what happened? Cyclist got some final kinetic energy plus, at this point, got some final kinetic energy because velocity is still 5 meters per second, plus some gain in potential energy because at that point the cyclist got some potential energy plus 200 joules. These 200 joules are the work done against the friction because during this way the cyclist spends 2000 joules of energy in overcoming friction. That should also be considered. Okay. Now, put the values. We know the work done. This is F into distance. Force is we need to find. Distance is 700 meters because this is 700 meters. Plus initial kinetic energy. What is initial kinetic energy? That is 3750. 3750 joules is equal to final kinetic energy. What is final? 937.5 plus what is gain in potential energy? This is 13743 plus this 200. So this will become F multiply 700 is equal to, take this 3750 on the other hand, 937.5 plus 13743 plus 2000 minus 3750, this 3750. So after this I should solve all these values. This will be 937.5 plus 13743 plus 2000 minus 3750 equals 12930.5. F multiply 700. So take 700 on the other side. So F will be 12930.5 over 700. So divided by 700 equals 18.47 newtons, which is almost equal to 18.5 newtons. This is our answer. of question number 2. Now, question number 3. Question number 3 is a block of mass 3 kg is at rest on a rough incline at 60 degrees. Okay. To the horizontal. A force of magnitude 50 Newton acting up of a line of graded slope of the plane is just sufficient to prevent the block from sliding down the plane. Find the coefficient of friction between the block and the plane. Okay, here we'll again draw our vector diagram which will help us in solving question. There is an inclined plane. This is the inclined plane. The angle of this inclined plane from horizontal is 60 degrees. There is a block of mass 3 kg. Okay. Since the weight always acts downward, 3 kg means 3 multiplied 10, 30 Newton weight. Just try to complete as much this diagram as possible before solving the question. That will help you a lot. This angle is also 60 degrees because this is always, these two angles are equal. So this is horizontal component which is 30 cos 60 degrees. This is vertical component which is 30 sin 60 degrees. Okay. Now, there is also a normal reaction force R acting perpendicular to the plane upwards. Now, the force of 15 Newton is acting upward. This is just a sufficient force which stops the block in going downwards. It means the block has an intention to move downwards. Therefore, the frictional force which is mu r, Fc is equal to mu r, is acting upwards because the block has an intention to go downwards. If the block get a chance, it will move downwards, so that's why the frictional force will move upward. Now, this is our vector diagram. Okay. First of all, what is R? Or you can say that this force plus frictional force is equal to the downward force because the sum of these two upward force is equal to the downward force. So we can write it as F plus mu r is equal to 30 sine 60 degrees. Okay. Now, F, this is 15 plus mu we are going to find, and what is R? R is equal to the horizontal component of weight which is 30 cos 60 because they are equal. So R is 30 cos 60 is equal to 30 sine 60 degrees. Okay. Now, this 30 cos 60, if you find this by calculator, it is 15. So this will become mu into 15 is equal to this 30 sine 60 degrees. So take 15 on the other side. 15 mu is equal to 30 sine 60 minus 15. and this will become, by solving with calculator, 30 sine 60 minus 15, which is equals to 10.98. So this is 10.98, 15 mu. So take 15 on the other side as well. So mu will be 10.98 over 15, and this will be equal to 0.73. So this is the value of mu, the coefficient of friction. This is our answer. Now, part 2 is the force of magnitude 15 Newton is now replaced by a force of magnitude x Newton acting up the line of greatest slope. Now this force, this 15 Newton force, now replaced by x Newton. Find the greatest value of x for which the block does not move. Greatest value, we have to find the greatest force for which the block does not move. For this reason, you should be very careful now, because I'll plot the diagram again here. 60, this is the block, this is 30 newtons, this is 30 cos 60, this is 30 sine 60, this is r, and now this is x. So this is also 60. Now in this case, if you read this part very carefully, find the greatest value of x for which the block does not move, means this x Newton is the greatest force which will not allow the block to move downwards, means it is sure, it is 100% sure that the block will move upward if it moves. It means there is no chance that the block is moving downwards. It will always move upward because x is the greatest. That's why now the mu r will be downwards, because there is no chance to move the block downwards. Block will always move upward if it moves. That's why there is a surety that mu r will move downward. Now in this case, this force x is equal to mu r plus sine 30 sine 60, because this force is equal to the sum of opposite force. Therefore x is equal to mu r plus 30 sine 60. So mu r means 0.73 into r is 30 cos 60 plus 30 sine 60. So x will be, to solve with the calculator, 0.73 multiply 30 cos 60 plus 30 sine 60 equals 36.93. 36.93 newtons, which is almost equal to 37 newtons. So this is our maximum force. This is answer. Okay. Question 4. Question 4 is also a very good question. We got two blocks. The block A and B of mass this kg, 4 kg and 5 kg respectively are joined by a light external string. The blocks rest on a smooth plane. The angle alpha, where tan alpha is 7.7024. The string is parallel to the line of greatest force. Block A, B is above A. Okay, all the information you know. The force of 36 newtons acts on B parallel. Find the acceleration of the block and the tension in the string. So we need to find two things: acceleration of the blocks and tension in the string. Okay, I have to draw the vector diagram again. I got this page or next page as well. I got some space on the next page as well, so I should be a bit easier to use this space. Okay, this is alpha, which is, I will not alpha, I'll take the value of alpha from here and I'll write later on. This is block A. This is block B. And these two blocks are connected with a string. And there is a 36 newtons force upward. Okay. Now, first of all, the angle alpha will be, I can find the angle alpha from here. Tan alpha is 7/24. So I can write it as alpha is equal to tan inverse 7/24, which is 16.26. If you want to check, you can find it from the calculator. This is 16.26. So this is 16.26. Okay, degrees. Now, the weight of this block A will always act downward. The block A got 4 kg mass, so its weight will be 40 newtons. This is horizontal component. This is also same angle. This will be 40 cos 16.26. This is the vertical component, which is 40 sine 16.26. And this is normal reaction RA. This is the and this is tension in this direction. This is tension. So these are all the forces applying on block A. Now for the block B, again the weight will act downwards. The block B got 5 kg, so its new weight will be 50 newtons. These two angles are same with 16.26, so this will be the horizontal component 50 cos 16.26, and this is the vertical component, which is 50 sine 16.26, and the tension, this is the tension in the string. This is also a backward tension, which is the reaction of this tension. So these are the two complete. Okay, this is the reaction of normal reaction of block B, which is RB. This is a complete vector diagram of this. So you must be very careful while drawing this vector diagram, because this is the main part of the question. If your diagram is correct, your question will be correct. Okay. Now, find the acceleration of the block. So for the acceleration, we need the resultant force, because I'll use the formula F is equal to ma, Newton's second law's formula. So this resultant force is actually the 36 minus these two backward forces. This force is pulling the block downwards. This is also pulling the block B downwards. So these two forces actually pulling the block downwards. So this is the force upwards. So resultant force will be this minus this minus this. So it will be 36 minus 50 sine 16.26 minus 40 sine 16.26 is equal to mass m. Mass means the total mass, because this force is pulling the both blocks. So this got 4 kg, this got 5 kg. So this will be 5 plus 4 into A. Now by calculator, this will be 36 minus 50 sine 16.26 minus 40 sine 16.26 equals 10.80 is equal to 9A. So take 9 on this side. So 10.80 over 9 is equal to A, which is A is equal to divided by 9, 1.2 meters per second square. This is the value of acceleration. Now I need to find tension as well. So tension, I can use any system, or block A or block B or both block A and B for tension, because the tension throughout the string is same. So that's why this tension will be, I'll use this block A system. So for tension T, from block A diagram, this again I'll use the Newton's second law's formula. This tension minus this, the resultant tension will be this tension minus this is equal to MA. So F is equal to MA. So this F means resultant force, which is T minus this. So T minus 40 sine 16.26 is equal to mass, the mass of the block A, which is 4 into A. So A, I know the value of A now. So T minus 40 sine 16.26 is equal to 4 into 1.2. So now this 40 minus sine 16.2 will go to the right. So this will become T is equal to 4 into 1.2 plus 40 sine 16.26, and after solving it by calculator, that is 4 multiply 1.2 plus 40 sine 60 equals 39 point no sorry yes, this will become 15.99, which is equals to almost 16 newtons. So there is a 16 Newton tension in the string. This is our answer of part first, the final answer. Question number 2, part 2. At a particular instant, the speed of the block is 1 meters per second. Okay, find the time after this instant that it takes for the blocks to travel 0.65 meters. Okay, it means we got the speed, which is initial speed, that is u 1 meters per second. I got distance as well, s is equal to 0.65 meters. I need to find time for this. So if you see closely, I can use the second equation of motion, which is s is equal to ut plus half at square, because I got the value of a as well, which is 1.2 meters per second square. So put the values. 0.65 is equal to 1 multiplied t plus 1 by 2 into 1.2 into t square. So this will become 0.65 is equal to t plus this will be 0.6 t square. So take this 0.65 on the other side. 0 is equal to 0.6 t square plus t minus 0.65, or I can write it as, let me check the space. Okay, I got this part, this space only. So I can write it as 0.6 t square plus t minus 0.65 is equal to 0. So this is a quadratic equation which I will solve. First of all, we need to make this equation a bit simple. I'll finish this point. I'll finish this point as well. There will be 100, there will be 10. So take the LCM. So this will be the 60 t square, this will be 100 t, and this will be minus 65. So this 100 will actually multiply with 0 and this will become 0. So I got final equation 60 t square plus 100 t minus 65 is equal to 0. Okay, now I'll solve this equation by midterm break method. So if I take something common to make my equation a bit simple, yes, I can take 5. 12 t square plus 20 t minus 13 is equal to 0. Now this 5 cannot be 0, so this will be 0, that is 12 t square plus 20 t minus 13 is equal to 0. So by midterm break method, I will get 2 terms inside, that is 26 and 6. So this will be 12 t square plus 26t minus 6t minus 13 is equal to 0. So take 2t common. So this will become 6t plus 13 minus 1 common, 6t plus 13 is equal to 0. So take 6t plus 13 common and I will get 2t minus 1 is equal to 0. So I will get 6t plus 13 is equal to 0. 2t minus 1 is equal to 0. This will be t is equal to minus 13 over 6. This will be t is equal to 1 by 2. So this is rejected because time cannot be negative. Therefore, I got t is equal to 0.5 seconds. This is the answer. Okay. Now, the question number 5. Question 5 is, we got a ring A small ring P is threaded on a fixed smooth horizontal rod AB. The three horizontal forces of magnitude this acts on this. Given that these three forces are in equilibrium, find the values of F and theta. Okay, so I'll make the diagram again because I need to work on this diagram. This is I got some space, yes, on the next page. So this is the rod, this is the ring, this force is F newtons, this is theta, this force is 7.5 newtons, and this is 4.5 newtons. This is 20 degrees and this is 60 degrees. This is ring T. Now there are a couple of approaches. You can go like Lami's theorem, or there are one or two more methods, but I always suggest my students to use this vector method, which is very easy and you can handle more than 3 or 4 forces, because Lami's theorem is just for 3 forces only. So keep in mind this one method, and this will applicable for all the for more than 3 forces as well. Okay, first of all I'll split all these forces into their rectangular components. This is my F cos theta because this is the horizontal component. This is F sin theta because this is the vertical component. In the same way, I'll split this force into its rectangular components. This is 4.5 cos 20 and this will be 4.5 sin 20. Okay, this is upward. Now this will be 7.5 cos 60 because this is the horizontal, and this will be 7.5 sin 60. So these are all the rectangular components. Okay. Since this ring is in equilibrium, therefore the resultant force on this ring is 0. Means there is no horizontal forces, there is no vertical forces as well. So since the ring is in equilibrium, therefore sigma Fx will be 0, means the sum of all the horizontal forces should be 0. So what are the horizontal forces? All the right side forces is positive, all the left side is negative, because x-axis is positive on the right side and left on the negative. So you have to fix one direction, means right side we used to take positive and left we used to take negative. So this will be F cos theta minus, this is the horizontal force, 4.5 cos 20 minus, there is another force, 7.5 cos 60 is equal to 0. So take these two on the right side. F cos theta is equal to 4.5 cos 20 plus 7.5 cos 60. So after calculation from the calculator, this will give me 7.98 newtons. Again because the ring is in equilibrium, so sigma fx is 0, also sigma fy is equal to 0 because there is no resultant force on the vertical as well. So in the same way, all the upward forces are positive and all the downward forces are negative. So f sine theta and 4.5 sine 20 are positive. This will become f sine theta plus 4.5 sine 20 is equal to or minus 7.5 sine 60 is equal to 0. So take these two on the other side. This will become f sine theta is equal to 7.5 sine 60 minus 4.5 sine 20, or by calculator this will give me 4.96 newtons. This is my f sine theta. Okay. So I know the formula for the resultant, which is f is equal to f cos theta square plus f sine theta square, because if this is a resultant force f, then this component is f cos theta and this component is f sine theta. So this f is actually the hypotenuse of this right angle triangle. So by Pythagoras theorem, f should be equal to this square plus this square. Now by putting the values, f cos theta is 7.98 square plus f sine theta is 4.96 square, and this becomes 9.40 Newton by calculator. So this is the resultant force. This is first answer. I need to find the angle as well. So for angle, I will use f sine theta over f cos theta equals, the value of f sine theta is 4.96, value of f cos theta is 7.98. So this will be cancelled with this. Sine over cos means tan theta is equal to 4.96 over 7.98, or it can be written as theta is equal to tan inverse 4.96 over 7.98, which will give me 31.8 degrees. This is my second answer. Okay. Now part 2. It is given instead of that force f and theta, this is new value of f 9.8 and this is new value of theta, which is 30 respectively, and the acceleration of the ring is this. Find the mass of the ring. So for this I'll use again the second laws, Newton's second law. F is equal to ma. So this F means the resultant force, which is horizontal, because the ring will always move to the horizontal, not vertical. That's why the ring will move towards the bigger force. For example, this is our resultant bigger force. So this resultant will be this minus these two. So don't forget to put the value of f and new value of f and theta. So this minus this is equal to ma. So for this, f is f cos theta minus 4.5 cos 20 minus 7.5 cos 60 is equal to MA. Okay, what is force? That is 9.5 cos, and what is theta? This is 30 minus 4.5 cos 20 minus 7.5 cos 60 is equal to m into acceleration is 1.5. So by solving this, the calculator, I will get 9.5 cos 30 minus 4.5 cos 20 minus 7.5 cos 60 equals 0.248. So 0.249 is equal to m multiply 1.5. So take this on the other side. This will be m is equal to 0.249 over 1.5. 1.5. This is 0.1. 0.166 kg. This is our answer, or 166 grams. This can also be